Okay, here we are back at the table of contents for our Learn course, and I'm going to go into lectures and to lecture handouts, and I'm going to download the push button example. Okay, this is going to be page 11, let's call it, of the notes, the I/O notes, and this is going to illustrate using interrupts. So let's go to the bottom and just write a bit of background info. So the purpose of this handout is to use an ISR to record a button push, and just some stuff that you need to know. The button reads 1 when not pressed, 0 when pressed. So maybe a little counterintuitive. What we're going to do, trigger the interrupt request on the button 1 to 0 transition. And the steps that we need to take, there's 3 of them. So the steps are these. 1, we are going to create the ISR. Then we will enable the IRQ at the button. And then we need to allow the IRQ at the processor. So by default, the processor will be ignoring these external interrupt sources, and we have to explicitly enable it. So step 1 is right here. This is how we create the handler, and this name is the same name that is found in the startup assembly file. So this function overrides the default handler in startup underscore LPC 17xx.s. So if you look in that file, it's assembly language, there is a definition for the external interrupt 3 handler, but it's just an infinite loop, that branch dot that I showed you on the previous page. And in the table, the vector table, the linkage to this function is declared as weak, and this is particular to the ARM assembly language and also their linker. So if you define that function elsewhere and you don't specify that it's weak, it will override it. So it's sort of a kind of like a compiler trick, I guess. So you have to use the exact right name for it to override or to be linked into your vector table. So this will now be the function in the vector table. If you look at it, it sets push button equal to true, button pushed equal to true, and it clears the interrupt. So let's go up to the top of the page here. And so right at the top, we include LPC 17xx.h. So we're going to do that for all the code examples that I do with the board, and standard bool just so I can use true instead of 1, and standard I/O so I can print just so that we can see this thing running. So we have a global variable here, button pushed, and it's initially set to false. The ISR is going to set it to true whenever the ISR runs, and then the main application is going to set it to 0. Well, what the main application will do, let's actually go down to our main. So it sets up the push button, so we'll get to that in a minute. But then if we look at the while loop here, while true, if the button is pressed, or button pushed is true, we're going to print button pushed to the console or to UART1, and then we'll set button push to false. So this isn't the best example because our main function isn't really doing much that's very useful, but it shows the technique to set up an interrupt service routine, which is what I want to illustrate here. Okay, so here's our queue handler. So whenever the interrupt request is received, whenever you press the button, so when you assert button down, if you're simulating in the lab, then the ISR runs, it sets button push to true, and then this line here clears the interrupt request, and this is at the button, or really at the interface on our microcontroller unit to that button. So IO2, that's general purpose IO port number 2. There's 4 of them on our microcontroller unit, and this one shifted over 10 positions on the right here. What we're doing is we're setting a particular bit. We're doing an OR equal, and we're setting bit number 10. Remember, the bits start at 0 and go up from there, which corresponds to port 2, pin 10. So port 2, pin 10 is connected to the push button. So we're kind of getting into the weeds here, maybe too much detail, but it's hard to avoid. This is the kind of stuff you have to do when you do embedded programming. Okay, so now let's look at the setup routine. It's actually pretty simple. There's only two lines there, 2 statements. So the first is, again, you see the IO2, so that's for general purpose IO port 2, and again we see this 1 shifted left 10 times, so that's for, that will correspond to pin 10 in this register that we're writing to. So we read the register out, and then we set that 1 bit and write the whole thing back. And what this is doing, so this is going to, I'm just going to pick out the parts of the term here. So N, enable int, so that's interrupt request, that's what that would be short for, on, and now this is the F here, and that is for the falling edge. So as the button value transitions from 1 to 0, when you press it and it becomes 0, that's going to trigger the interrupt request from the port to the processor. So this is step number 2 in the steps below, where you're enabling the interrupt request at the source. And then step number 3 is allowing that request through at the processor. So first of all, NVIC stands for Nested Vectored Interrupt Controller. So that's the interrupt controller. What we're doing here is enabling external interrupt 3, which is the push button. So we're going to allow IRQs from it to interrupt the processor and be handled. And whenever those happen, then the handler down below that we defined in step 1 gets executed. And that's the whole application there.